Singapore's Gardens by the Bay is unlike any other garden in the world. Engineers have to build 2 mega glasshouses and control the weather within, while shielding against heat radiation and tropical monsoons.
If the system fails, that would be a disaster.
They have to source plants from as far afield as Mexico. Even build unique supertrees that meld concrete and steel with lush greenery. If engineers succeed, they will create the 21st century's New York City Central Park and raise the bar for future green spaces. Singapore is one of the world's most densely populated countries. Over 5 million people live in a land area smaller than New York City. To make such a small and highly urbanized place livable, Singapore grows green lungs. Incredibly, plants cover almost 50% of the country. Now, the nation is embarking on one of its most ambitious greening projects to date, Gardens by the Bay. It features not 1, but 3 massive gardens the size of 177 soccer fields. And just like the famous Eden project in Cornwall, UK, the gardens will contain an array of plants from around the world to create an international showcase of flora. The project's most daunting challenges, however, are made of concrete, steel and glass. 2 vast conservatories have to display hundreds of plants and flowers from much cooler climates. But how do you chill giant glasshouses in one of the hottest regions in the world? Or design them to shield against Singapore's tropical monsoons? In the heart of the complex, mammoth supertrees form unique vertical gardens. 18 towering structures, up to 50 meters high, will not only support plant life, but also an aerial walkway and restaurant. The challenge is, no one has ever attempted such designs before. The team behind Gardens by the Bay are only too aware that they face an uphill battle, and the stakes are high. The Singapore government is paying $800 million to make the project a reality.
That is the promenade, that's the promenade, and that is a marathon.
Ma Bao Tan, the former Minister of National Development, has been a driving force behind the gardens.
This particular garden is one of those things that we hope, can cement our status as a model sustainable city of the future.
Engineers plan to build Gardens by the Bay on close to 11 million square feet of prime real estate, here on Marina Bay. The freshwater reservoir is also a multi-billion-dollar entertainment hub, featuring the world's largest Ferris wheel, a state-of-the-art dam, and the Marina Bay Sands Resort. Gardens by the Bay will be another jewel in the crown.
This is the area of water. And then in the centerpiece.
Landscape architect Andrew Grant is in charge of master planning the southern part of the project. His speciality? Creating futuristic and sustainable buildings and environments. Over the last 20 years, Grant has spearheaded some innovative spaces in the UK for clients like Rolls-Royce and the British government. Gardens by the Bay will be his biggest project yet.
We spend a lot of time just thinking what's the core idea that's going to hold this whole thing together. We thought, the orchid is a really interesting sort of starting point because it's the national flower of Singapore. It's the most cosmopolitan plant species, and there's over 25,000 species of orchids around the world. And it seemed to me that Singapore was all about that, so let's get this sort of melting pot of different things going on. And so we started to think about how we could structure the garden around the idea of an orchid. The paths were informed by the stem system, the gardens were the flowers, and it suddenly all starts to make sense.
On site, engineers are more worried about securing the footprint where Grant will execute his vision. What looks like solid ground is actually reclaimed land. Beneath this section of Marina Bay is a marine clay layer over 30 meters deep. Often called black toothpaste, marine clay is dangerously soft and highly unstable. Without the right precautions, it can prove fatal.
Started with an underground explosion.
The body of one worker confirmed dead was recovered.
In 2004, a standard excavation on an underground line for the Mass Rapid Transit System causes a catastrophic collapse, killing 4 workers and damaging nearby Nickel Highway. The danger of marine clay is felt most in the southern part of the gardens. Marine clay could destabilize the buildings and cause severe damage. Geotechnical engineers study all the options before them. Only one indicated the best result. Cast in situ piling. In cast in situ, a borehole is first drilled past marine clay into a stronger layer, in this case, alluvial soil up to 60 meters deep. Then a prefabricated steel casing is hammered down to the same level. After a steel-reinforced cage is lowered into the casing, high-strength concrete is poured in to solidify the pile. When the concrete is set, the permanent structure supports the soil around it. By constructing over 1,000 cast-in situ piles, engineers can overcome marine clay and secure the foundation. Another challenge remains: how to prevent the muddy construction from polluting Marina Bay, which supplies 10% of the country's drinking water. The quick answer: use of the coastal defense wall, which shields the site's 200-meter coastline. Made of cast-in situ concrete, the wall prevents soil or construction material from discharging into the bay and polluting it. To ensure the wall is impenetrable to even muddy water, it's covered with a silt fence. The fence is made of a white polyfelt material that is woven tightly enough to filter out soil particles in water. To top it off, engineers order a 24-hour watch on the wall for any movements or leakages. There are no straightforward solutions at Gardens by the Bay. Part of what will make it a unique attraction is that 60% of its plants are not found in Singapore. Many of them come from drier and cooler regions around the world, like Australia and Europe. To house them, engineers will have to build 2 massive conservatories. But how can they create and control the low temperatures needed inside, on an island just north of the equator? And how do you protect what are essentially fragile glasshouses? The one challenge facing Singapore's Gardens by the Bay stems ironically from its prime waterfront location. There are no surrounding buildings to shield some of nature's finest specimens from the intense tropics. Monsoon rain is just one threat facing the garden's largest structures. Glass-covered conservatories. When it's not pouring, Singapore's sweltering tropical sun will bake them, killing the expensive plants inside. To avoid the nightmare scenarios, engineers work feverishly to devise unique solutions. Architect Paul Baker oversees the team.
We did a massive amount of brainstorming and group discussion. And as a team, we sat down and we thought as freely and as clearly as we could about the objectives and the problems we had to solve.
First and foremost, Baker and his team need to guard the conservatory's glass domes against high winds and heavy rain. The answer mimics the human body's natural defenses. An intricate system of 28 steel ribs, called arches, will reinforce the exterior of the conservatories. Like the human ribcage that protects our vital organs, the arches keep the glass domes safe by absorbing and deflecting strong winds. Another layer of ribs strengthen the glass domes themselves. A network of hundreds of steel frames, called grid shells, bind the pieces of glass together. In theory, the shells help the glass resist wind pressure while preventing leakages due to rain.
We looked and studied a long time the shape of the grid shell, and we've ended up with actually a triangular section to allow minimum shadow and to increase the perception of lightness. Not in terms of brightness, but in terms of lightness of structure. We're always striving for elegant forms that give us simplicity and look effortless.
The solution sounds like a winner, but the question on everyone's mind is, will it actually work? The only way to be sure is to put the design through some serious punishment. Over the next 48 hours, engineers will place a mock-up of the conservatory facade in this large pressurized chamber and then pummel it with the elements. Simulated thunderstorms will test the facade's waterproofing, and computer-aided wind pressure will push it to the limit.
1 minute.
Harold Pates is the 43-year veteran engineer in charge.
If the system fails, that would be a disaster. But we are definitely sure it will not fail. We are very confident in our design work stuff.
During the pressure test, Harold constantly monitors the facade as air around the chamber reaches levels of over 200 kilograms of force per square meter. The immense pressure can bend the glass, and Harold has to make sure that the bending is no more than 20 millimeters.
When you see here, there will be anything happen on the pressure itself, it will be stopping. Then we know there is some problem, something is happening. Comes to 300 now. Now we will stay for 1 minute, then release the pressure again.
As the pressure increases, so does Harold's blood pressure. The readings have to be precise, or the whole plan could fall apart.
We have an emergency stop. We will immediately release the pressure totally, and then we will check on the mock-up itself what may happen.
In the end, the mock-up passes both the rain and pressure tests.
Black and white.
But Harold isn't leaving anything to chance. There is one more extreme scenario for the facade to survive. These men are simulating hailstones.
When you see from the glass specification, certain impact is already in the design included. So if you put a stone on this or something like this, it may crack, it will not break.
The secret behind the strength of the glass can be found in one of the most common objects in the world: car windscreens. Windscreens are made of laminated glass, a type of safety glass that holds together when shattered. And just like the windscreen, the glass on the facade passes the test with flying colors. With the experiment a success, engineers can now contemplate the construction of the conservatories. Each building's frame will contain over 200 steel grid shells. But installing is no easy task. Assembling the massive steel arches presents an entirely different challenge. 28 of them span the conservatories and weigh a staggering 1,000 tons, equivalent to 500 cars. Trying to lift one of these arches into place will be a near impossible task because each one measures 150 meters. On top of that, the delicate curves of the arches require highly accurate manufacturing techniques. To find the solutions, engineers hire the Yongnam Steelworks, one of Singapore's largest steel prefabrication facilities. 4,000 steel elements for the conservatories will be measured, cut, and welded to exact specifications here. Yongnam uses advanced 3D modeling programs to create a detailed map of each bend and twist in an arch. Then the diagrams with step-by-step instructions are printed for the supervisors and welders on site, allowing them to pinpoint exactly how to put the complicated pieces together. Engineers also come up with an ingeniously practical solution to install the 150-meter long arches. Split each one into 8 smaller segments. The segments are then easier to transport and take up less space on site. As each piece is finished, it's trucked carefully to its destination with a police escort. Once on site, the arch is hoisted up and prepared for its final installation. The mission today is to bolt the longest of the arches into place. A 22-meter giant that weighs 20 tons. For the men, lifting it is a nerve-wracking affair. They could knock something out of place, or worse, damage the expensive segment beyond repair. The key part of the process is to balance the arch onto temporary steel struts. They will support the arch so that workers can bolt it into place. Joining the arch to the next one has to be accurate to the millimeter. It's like gluing a model together, but on a mega scale. After a grueling 48 hours, the segment is finally locked into place. But engineers still can't breathe easy. In order to complete the rest of the arches quickly and safely, they realize that they have to assemble a lot more support scaffolding than is typically used. And that is a problem. Gunasekharan is the construction manager.
You can see the size of the dome and everything, but we cannot simply build the dome on only itself by building so much scaffolding, starting from the base to go and support the things. So it will be a very big challenge.
A huge amount of scaffolding is not only impractical, but also creates a cramped and unsafe working environment. To make matters worse, the tight timeline means that engineers have to build a conservatory's arches, grid shells, and groundworks all at the same time. This will inadvertently lead to massive congestion above and below ground. Engineers search for solutions. In the end, only one fits the bill: crash decks. They are essentially interconnected giant towers of steel columns and beams that form spacious working platforms above, while creating sufficient room below to allow other construction to continue without congestion. The crash decks erected at GardensByTheBay will be one of the world's largest. Gunasekharan can't be happier with the decision.
The name came, it is going to prevent the things which is going to crash down. It's a supporting element. In fact, it is a big safety platform.
The plan is to simultaneously construct crash decks while installing the conservatory's arches and grid shells. At the crash decks, engineers use a team of cranes able to lift 300 tons to hoist the beams and columns into position. The most amazing part of the process is that no welding at all is used to join the sections. They are bolted together securely by hand. Installing platforms this high above the ground is extremely dangerous. So good safety procedures can be the difference between life and death. Supervisor Suresh ensures that the rules are sacred.
Then I go to working in that area. I use this harness, okay? This harness. Hook for this lifeline, okay? This lifeline. This one I hook it, okay? Lock it. Then I go into work.
The harness ensures that the workers will only fall 2 or 3 meters if an accident occurs. While they hang in mid-air, a rescue team will be dispatched to save them.
This job is a very dangerous job also. Okay, I follow the safety, okay, so no problem. So now I have 46 workers. Small injury, any accident, still no coming. This one I finish, now is more work, I have more tension. Going to finish, I very happy ready.
As engineers race against time to install the rest of the arches and grid shells, landscape architect Andrew Grant is focusing on making the other giant structures in Gardens by the Bay a reality. 18 super trees. They will be incredibly tall, up to 50 meters high. Like real trees, they will carry life within them. During the day, their canopies will provide shade for visitors. At night, the canopy will come magically alive with colorful and specially sequenced lights. But to make this wild concept a reality is easier said than done. When landscape architect Andrew Grant first proposed the Supertrees, it was born from a desire to create large vertical gardens to display tropical plants. It will be like having an ancient rainforest in Gardens by the Bay. But a key inspiration for his design came from a much drier climate. The Valley of the Giants in Western Australia. Located in the Walpole-Nornalup National Park, it's home to a variety of enormous eucalyptus trees, some over 400 years old.
You go through this sort of typical sort of eucalyptus sort of forest, which is about 15, 20 meter high trees, and you come to this sort of little core of just the most amazing forest where the trees are 60, 70 meters high. And you can get it into the canopy in this aerial walkway, which is 40 meters up in the air. And it's just such a spectacular experience. So I thought, you know, how can we do something like that at the heart of this project?
Grant's vision is to recreate the ancient eucalyptus trees in the gardens. Like the real thing, it will support plant life, an aerial walkway, and environmentally sustainable functions. It will even cater for a restaurant. But Mother Nature has had millions of years to perfect her design. Today's engineers have just 3 years to get the job done. The key concern for engineers is finding an ultra-fast and strong building solution for the trunks of the 18 super trees. Concrete will make a sturdy core material, but the conventional cast in situ method is prone to constant weather delays. In the end, they take their cue from Singapore's government-constructed housing works. Over 80% of the country's citizens live in these residential flats. To meet the high demand over the years, the government relied on precast concrete construction. In precast concreting, blocks are produced rapidly without delays by being cast and cured indoors in a factory before being transported to site and installed. Engineers intend to replicate the same process to build the Supertrees in time. Edwin So is the senior manager.
I've been in this precast business for 20 over years, so it's exciting to see a different type of precast we're doing right now. The most important part of developing the Supertree is the foundation. So the foundation will be able to support the structures that is going up, which is the trunk we're talking about. And the trunk makes up of panels which will stack on top of another.
The Supertree's precast concrete panels, each weighing up to 9 tons, will be hoisted by this crawler crane. By stacking 28 of these panels, So will be able to form the trunk of this 42-meter high super tree. The biggest challenge of the hoisting procedure is to align the panels to steel continuity bars set within the walls. They help to reinforce the trunk and form the backbone of the structure.
We cannot afford to have one plane out of tolerance, so we have to align it carefully. If we don't do it properly, it may crack the panel. And once this panel is cracked, we can actually use them because the structural integrity would be adversely affected.
To hoist a single panel to the top of the trunk and install it will be a 2-hour mission. Suspended like a pendulum 40 meters in the air, the 9-ton concrete panel is tricky to control.
Even though we have gone through this lifting a few times, so whenever I see the lifting, I still get nervous. So the wind will have some effect on the panel when doing installation by swaying it here left to right. So our man has to be careful.
Now slowly the rope down, so be careful then.
It's a delicate process aligning the panel to the continuity bars.
Left. Slowly boom left.
Like putting a thread through the eye of a needle. After a tense hour of negotiating the final part of the lift, the panel is safely lowered into place. One super tree is now fully grown. Another 17 to build.
When you see it's being placed in final position, you know you have done the work. It's a great job to be installed in the final position.
Creating gigantic trees from concrete and steel make Gardens by the Bay truly unique. But the project must also support real trees if it's to qualify as a garden. That's easier said than done. No matter how smart they are, engineers can't grow trees overnight. Besides, the place is literally a construction site. It would be impossible to grow anything here. The solution is to purchase millions of dollars worth of trees, flowers, and other plants. Not just from Asia, but also from around the world. It's a radical idea, but a logistical challenge. Whether they arrive by ship or by truck, the plants have to be stored in their thousands in temporary nurseries near the construction site, giving them time to grow and acclimatize before being permanently displayed. Among the mega plants transported to Gardens by the Bay are 4 500-year-old olive trees from Spain. Transporting at night allows the wide loads plenty of room on the streets, although sometimes it's still a tight fit. An hour after leaving the ship, these resilient old trees arrive at the nursery. But enormous exotic trees are not the horticultural team's only targets. Local Melaleuca trees, or tea trees, over 4 stories tall, are being transplanted from a road work site in eastern Singapore. Boon Gee is the National Parks officer in charge.
Basically, what we're trying to do is recycling this tree and then rescuing this tree that will otherwise be affected by the development projects. And these trees are special in the sense that they are huge. They have been there for almost 20 years, and you will be using it for our gardens later. So this is actually very, very valuable stuff for us.
In what will be a 3-month green engineering feat, Boon Gee and his team face the challenge of moving 16 tea trees. At each tree, they have to first dig a huge trench around it, which detaches its roots from the surrounding soil. Then a waterproof tarpaulin is wrapped carefully around the root ball to protect it during transportation.
This tree alone, this afternoon we have taken 1 whole day to actually take this tree up. So it's actually a lot of work, a lot of planning, a lot of resources involved.
Upon reaching the site, workers fasten a steel cage around it. This will reinforce a new root cover, which will contain a soil mix that is specially formulated for trees. For Boon Gee, getting this final mix right is always a gamble.
We can't prescribe a standard formula for all the trees that we transplanted. The worst case scenario is after spending so much effort in bringing this tree in, whether from overseas or from local, and then the tree will die. So far, the mortality rate is actually quite low. We're actually quite happy. We are talking about 10% out of the total number of trees that we have salvaged.
Water and lots of sunlight will hopefully rehabilitate this tree in time. But the same sunlight that is helping to keep it alive is proving to be a serious obstacle at the garden's largest structures, the conservatories. It's taken hundreds of workers under a year to complete the framework of the conservatories at Gardens by the Bay. A miracle finish for such massive structures. Engineers will need another miracle if they are to prevent Singapore's tropical sun from causing a meltdown inside. The problem starts with a conservatory's designated role to exhibit cool climate plants. The trouble is they are essentially glass houses. Typically built in cold weather places, glass houses trap sunlight and heat to encourage plant growth. In this case, engineers have to somehow modify the process. But how do you repel heat to cool a place down while still trapping the right amount of sunlight in which to grow plants?
I think that this particular project is all about the plants. It's all about making an environment that is good for plants as well as for people. So we started from absolute basic principles. We have a problem of balancing the light that's required for the plants to grow and to flourish against the heat that potentially will come into the building. So our whole debate is really balancing the light and the heat.
Baker and his team analyze idea after idea. They test their concepts by building prototypes. They have to find answers that will help maintain an indoor temperature as low as 16 degrees Celsius, while trapping 45,000 units of light, or lux, in the conservatories. In the end, they decide that the best solution is to cover the conservatory with customized state-of-the-art double-glazed glass. Engineers manufacture some 3,000 pieces of glass, each one weighing up to 350 kilograms, to fill one conservatory.
Okay, bang, way up, bang, slowly up.
Every piece is shipped from China and comes with a hefty price tag. No one wants to drop the expensive hardware. The magic of the glass is invisible to the naked eye, but can be found on its surface and within it. One of its main components is metal oxide. Engineers found that by adjusting the metal oxide content to just a few microns thick, they can achieve the right amount of light transmission into the building. They then finish the inner surface of the glass with a low emissive or low E coating. Emissivity refers to the ability of glass to reflect or absorb heat. So they have effectively turned each piece of glass into a mirror that controls the light passing through it. But high-tech glass alone isn't going to give engineers the control they seek over the elements.
Singapore has got a constantly changing climate, so to have a static envelope would not be logical. The logic that we pursued, and the most sustainable story, is to allow an envelope that is constantly changing.
So what can engineers add to the conservatory that will give it the power to respond to climate changes? Computerized sunshades. Located above the glass, they work like the sails of a boat. As the sun passes over the conservatory, particularly at noon when it feels hottest, temperature-sensitive cells beneath the glass trigger it to roll out. On a cloudy or rainy day, the shades will sense the change and automatically retract, maintaining cool temperatures in the conservatory 24/7. Even though engineers have armed the conservatories with advanced glass and shading technology, their mission to cool them still isn't complete. The buildings will need mega chillers in order to take temperatures down to as low as 16 degrees Celsius. And the Singapore government isn't satisfied with using conventional cooling technology. They want an energy-efficient solution to set a new benchmark in sustainability.
Right from the start, our brief to the engineers was you must The energy consumption in this place cannot be more than what an ordinary office building would host.
A simple problem has quickly become an ambitious target that engineers have no choice but to meet. Engineers at Gardens by the Bay are on a tight schedule to cool the conservatories in an eco-friendly way.
There is no one simple story. It's incredibly complex. We've done conservatories elsewhere in the world. Here, to do it sustainably was the biggest challenge.
The team quickly reassessed their problem. Outside temperatures in Singapore often soar above 30 degrees Celsius. The air conditioning in the conservatories must somehow reduce temperatures inside to as low as 16 degrees Celsius. On top of that, they also have to ensure they don't use more power than a standard office block. It's an unconventional order.
It's been a key part of the story, as you would hope in a building.
Climate engineer Patrick Bellew has an unconventional idea.
You know, what you're looking at when you have a climate like Singapore is how do you make buildings more energy efficient? And what you have here is lots of heat. How do you make heat? How do you turn heat into cooling?
The solution, the liquid desiccant cooling system. Essentially a dehumidifying system, it contains a concentrated solution of lithium bromide dissolved in water. This is sprayed into hot and humid air drawn in from outside to absorb its moisture. The dry air then passes over a cooling coil before being pumped to the conservatories as chilled air.
When you buy an electronic gadget in a shop or a handbag or a pair of shoes, you always find a little sachet of desiccant in the bottom. That's a solid desiccant. That is a material that absorbs moisture, and that takes the moisture out of the air and reduces it from 90% humidity to 30% humidity. We can then cool it down using a lot less energy.
That solves the cooling problem, but engineers want to make it even more energy efficient. They discover that the answer lies within what Singapore already has in abundance. Trees. The country's National Parks Board is responsible for 3 million of them. They generate thousands of tons of garden pruning a month. What if this massive amount of garden pruning is not discarded as waste, but recycled to produce fuel to generate electricity? This is the biomass generator. A smaller version will be built at Gardens by the Bay. What they do here every month is to take those thousands of tons of prunings and chip them into manageable sizes. These wood chips become fuel for the huge boilers to burn, which produces steam. The steam drives a turbine, which then generates electricity to power the conservatory's chillers. Even waste heat from the turbine is recycled. The generator directs it to a heat exchanger, which transfers more steam, and ultimately, more electricity. The entire process is called the cogeneration system.
We've come up with an energy strategy for the whole project, which is based around waste materials. So in fact, the power that's generated on the site, the cooling and the hot water is all done using waste wood.
But the engineer's work doesn't stop here. The cogeneration system creates other types of waste, other than heat, that have to be dealt with. Wood ash is recycled into fertilizer. Smoke is also treated into barely visible gas. However, standard factory chimneys exhaling gas at Gardens by the Bay will be unacceptable. Only one structure on site can properly disguise a chimney: a supertree. Engineers have chosen this 37-meter behemoth to contain a chimney stack made of carbon steel. It sounds like a relatively simple plan, but it will take 35 men and 3 cranes to complete the lift.
I don't see anyone else giving a signal.
The team has to lift the 18-ton stack vertically, 80 meters into the air, before slowly lowering it into the tree. Lo Kian Bing is the project director.
The lifting and the insertion of this chimney into the super tree is probably one of the toughest work for this MPAC project here.
For such a dangerous operation, it will not take long. Engineers estimate that if all goes well, it will be all over in just 2 hours. During the procedure, changes in wind speed are constantly monitored. Even a small puff of wind requires swift action by the ground crew. 2 men with good head for heights are lifted 37 meters up to the canopy. Their job will be to guide the stack gently into the chimney. The men keep a careful watch, as do the ground crew below. There are just millimeters of room around the opening. In just under 2 hours, one tastefully hidden chimney stack is now in its final position. With the last hurdle out of the way, engineers concentrate on putting the finishing touches to the super trees. Plants that have sat in the nursery for months find their final resting place attached to the trunks of the super trees. And workers hanging 13 stories in the air give the conservatories a thorough cleaning. The team behind one of the world's most remarkable gardens has truly defied engineering logic. They've created exciting sustainable technologies, tamed unstable ground, and are well on their way to building a unique megastructure.
Ladies and gentlemen, let us welcome our guest of honor, Mr. Ma Bao-Tan.
The man who helped kickstart the project is only too pleased to give his thanks and lend a hand with the last piece of glass at the conservatories.
It really is something which I think everybody is responsible for. I mean, from the time we mooted the idea, bringing the various planners together, the various experts together, and then now to see it really beginning to take shape, I think is tremendously satisfying.
Those involved can't quite believe that it's almost all over.
This is a really exciting stage. I mean, for me to come and see, the site, from drawings where you've done 3D fly-through computer models, and then suddenly come and see that.
We always are looking for new things to do, but this is as good as it gets in many ways. The buzz, the thrill you get looking down on this amazing creation, and to have been a part of it, it's just been a real honour, and it's been great fun as well.
Gardens by the Bay, a megastructure unlike any other, where cutting-edge engineering meets the green designs of tomorrow.